All right, we're going to look at some finding derivatives, and we get to use our derivative rules. So we're working on derivative rules. So here we're going to find the first and second derivatives. So the second derivative is simply the derivative of the first. So let's find the first derivative. And remember, notation wise, we could write this as s prime or ds dt. This is telling us that we're taking the derivative with respect to t. And this is just going to be basic polynomial. So we're going to be using our power rule. So essentially, there's a 6 hanging out because he's a constant multiple. We're going to put the 4 exponent out in front and then subtract 1 from that exponent. So, and then we have a -4 just hanging out. And then we're going to put the 6 in front and subtract 1 from that exponent. So essentially, when you have x to a power, the derivative of that is simply number out front and subtract 1. But then we also have a property that says if you're doing the constant multiple of something, so I'll just say cx for this example, then essentially you can just, that constant multiple can just sit out front while you take the derivative of the rest of it. So, we found our derivative, yay. Now we just got to simplify because that looks terrible. Okay, so 6 times 4 here is 24, and that'll be t to the, oh, why did I write -3? I do knew, because I was thinking ahead. So -1, which would be cubed, and then 4 times 6 is, well, still 24. Oh, I did the same thing here. Again, thinking ahead, -1, so that's a 5. All right, so this is the first derivative. So now for the second derivative, our notation, we can do s double prime, or we can do second derivative of s with respect to t. And there's our notation there. And same rule again, same rules again. So we've got a 24 hanging out. We're going to put the 3 out front and subtract 1 from the exponent. 24 hanging out, 5 out front, and subtract 1 from the exponent. And so then we'll just simplify this one. So 3 times 4 is 12, carry the 1, so that's 72 t squared minus 5. Well, why did I don't know what's going on. I'm just writing random stuff here. So 5 times 4 is 20, carry the 2 and t to the 4th. And so there's our first and second derivatives. All right, let's check out the next one. All right, so this one also is asking about first and second derivatives. Oh, this one actually has a rule in it that we have not talked about yet, but we can do it fairly easily. So first off, we can rewrite this second one so that it is not a fraction. So I'm just going to rewrite this first. This is 9x to the -4 minus 5x to the -1. Okay. So we're just going to rewrite this and then, oh, never mind. This is not the one I was thinking of, I guess. Okay, so now let's take that derivative. So y prime or dy dx, 9's hanging out, -4 out front and subtract 1. So you can do this. Now, keep in mind you are subtracting 1. So that's -4 minus 1, which makes a -5. This power rule, this exponent rule, you can do this with fractional exponents, negative exponents, positive exponents. So really just any real number as your exponent. So it's going to look like this. And again, be careful. This is -4 minus 1 and -1 minus 1. So then we'll just simplify this. So this is 9 times 4, which is -36, x to the -5. And then this is going to be a +5, x to the -2. And I'm going to leave this like that for when I find my second derivative, but then I'll also go in and put that back kind of how it looks without the negative exponents. So second derivative, we're just going to put that -5 out front, subtract 1, put that -2 out front, and subtract 1. And so then just multiplying those together, 5 times 6 is 30, carry the 3, and minus 10x to the negative 3. And so then if you look right over here at the first derivative, so all we've done, remember, a negative exponent means 1 over that. So it ends up putting it on the bottom. So you see that x to the negative 5 just goes to the bottom. And then this x to the negative 2 is just going to go to the bottom here. And then the same here. So you see that negative 6 just ends up in the denominator, and then that x to the negative 3 ends up in the denominator. So nice and sweet. All right. So that was just using power rule. So this one, we're going to use the product rule. So it says actually to do it 2 ways. Looking at this is just a polynomial times a polynomial. So we can use the product rule to figure this out, or we could just actually multiply them together if we wanted to. So it doesn't matter, you'll get the same answer either way. So let's just look at it both ways. So first, product rule. And so the way they're doing it is, so usually I think of it as the derivative. No. So let's say that I'll just do it with y because they did, but let's say your two functions are f times g. So y prime is f prime g plus g prime f. So derivative of the first times the second plus derivative of the second times the first. But notice this is addition and multiplication. So order really doesn't matter. So you could do fg prime plus f prime g. You could swap those around. And it looks like, let's see the way that they're writing it. They've got the u here. So this must be v prime. And then they've got the v here. So this one must be u prime. Okay. So just make sure that you're kind of mixing them together. So the way this one is written out, and actually I'm going to rewrite this second one real quick as 8x plus 9 plus 4x to the negative 1. That way I can use my basic power rule there. So the derivative here, the derivative of 8x, that's just linear. And remember, derivative gives slope. So the slope is just the number in front of x, right? So that's an 8. But you can also think of it as 8x to the first and apply that power rule. So you'd have 8 times exponent out front and subtract 1. Notice that's just an 8, right? Also for that second one, this is just a constant, and constants are horizontal lines. So what's the derivative of a constant? Well, it's 0 because that's the slope of a horizontal line. So here we go. For the derivative, we're going to have 8 plus 0. And then notice that's going to be minus 4x to the negative 2. So negative 1 put out in front, and then subtract 1 from the exponent. And now the derivative of the first one, which is going to be 18x plus 0, right? So I got 18 by putting the 2 out in front, and then I subtracted 1. So 2 minus 1 is 1. So it looks like this, which doesn't look real great. I would definitely want to simplify that if I were writing this down. But now when you use the product rule, you don't really need to multiply it out when you're done. That's kind of the reason for doing it in the first place, is not to have to multiply it out. But I would fix this just a little. So 8x plus 9 plus 4 over x times 18x. So, or sorry, yeah, times 18x. So now for the second one, they want me to go ahead and multiply it out first, then take the derivative. So let's look at doing that, and I'm going to multiply it up here. So we're essentially just, well, use that color. Okay, so we're going to put the 9x squared through to everybody. So that's going to be 9 times 8, that's 72x to the third, plus 81x squared, plus 9 times 4 is 36. And notice that x, the 1x in the bottom, and the 2 x's on top will leave you with 1x. All right, so now let's put the 4 through to everybody in the second one. So plus 8 times 4 is 32x. 4 times 9 is 36. And 4 times 4 would give me 16. And then I'm just going to pull that x up to the top. All right, so it looks like that. And then we can combine any like terms. So let's see, we've got 72x to the third. As far as squareds, we only have the 1. So 81x squared. X's, we can put these two together. So 3 plus 3 is that 68x. And then we have a 36. And then we have the 16x to the negative 1. So now when we take his derivative, it's just nice power rule all the way through. So 3 out in front, which would be 216x squared plus 162x plus 68. Remember, the derivative of 36 would just be 0, and then minus 16. It'd be x to the negative 2, so that's over x squared. And this here, our final answer here, and this here are actually the same things. So you could check that out. So whichever one you prefer, unless the rules tell you to use the product rule, then you really need to use the product rule. All right, so this one is going to be using the quotient rule. So let's check out the quotient rule. So the quotient rule, if you think of your function as f over g, then his derivative is f prime g minus g prime f divided by g squared. Rowan, go back in the other room, okay? So derivative of the top times the bottom minus derivative of the bottom times the top. So let's check that out. So for this one, f prime, we're going to do the derivative of the top, which would be 12t times the bottom, unchanged, which is 8t squared plus 9t minus 9, minus the derivative of the bottom, which would be 16t plus 9 times the top, 6t squared minus 5, and then all of that divided by the bottom squared. So there it is in all of its glory. If you were to multiply this out, it would simplify. I wouldn't touch the denominator, but on top, we could go ahead and look at this. Let's just put that 12t all the way through. So we're going to have t to the third, 8 times 2 is 16, carry the 1. And then t squared, 9 times 2 is 18, carry the 1. And minus 9 times 2 is 18. No, that's another 9. So 108. All right, now here we're going to FOIL, but notice also that there's a negative in front of everything. So we're going to have negatives for everything. So we're going to have minus, it's going to be t cubed, and then 6 times 6 is 36, carry the 3. And then we're going to have, let's see, 16t times negative 5, but because of the negative out front, that makes it a positive. And that's going to be 5 times 6 is 30, carry the 8, or carry the 3. All right, so it looks like that. For the inner, we're going to have 54t squared. And remember, that's a minus because that minus out in front. And then for the last, we would have minus 45, but the minus comes through, makes it plus 45. So notice these actually cancel out, which is kind of interesting. 108 minus 54 is 54. And then negative 108 plus 80 is going to be minus 28t. And then we'll have the plus 45. So there's our numerator. And that's where that came from. And then our denominator is just that trinomial being squared, that quadratic. All right, not too bad, right? Number 5 has a nice e in it. So the derivative of So this is actually, I think, our last rule here. So the derivative of e to the x is actually equal to e to the x, kind of nice. So let's look at that. So when we do this, so there's no putting an exponent out front or anything like that. This one does have a bit of a kick to it. And that's that this denominator this numerator is not just an x. So actually what we can do is write this kind of generically and say that the derivative of e to, say, the ax, where a is just some number, is equal to ae to the ax. So this would generalize that. And then we can use this fact to find our derivative. So let's look at that. So we'll have y prime equals, oh, actually we have to do it in both, don't we? He's got a -1 in front of him. So 5's just hanging out. And so now then, according to this rule in yellow highlighter down here, we're going to put the a in the front, and then we just rewrite it. Okay, so plus, we're going to put the 4 in the front, and then we just rewrite it. So this is going to give me -5e to the -x plus 4e to the 4x. And if we wanted to, we could actually put, because of that negative exponent, we could put this on the bottom if we chose to. So that's what it's going to look like. Oh, you found a penny. Very nice. Oh, you found some candy. Why don't you take that into the other room and eat it, okay? You can have it. All right, so I think we've covered all of our rules here. So this would be the quotient rule. It also has that e to the w in it. Number 7 here wants the derivatives of all orders. So this is just notation. Also, looking at this one, it kind of has a triple product rule going on. You can leave it that way, or you could multiply it out and do it. But let me just kind of show you what would happen with that. So let's say that y was equal to f times g times h. So we had 3 functions. So if you think about just kind of grouping, it doesn't really matter which way. If we do the first one and then the second 2, watch what's going to happen. So the derivative would be derivative of the first times the second plus derivative of the second. Okay, now the derivative of GH is an additional product rule. Product rule is derivative of the first times the second plus derivative of the second times the first. So that's the derivative of the second and then times the first. So see, derivative of the first factor times the second factor. Derivative of the second factor times the first factor. Now watch when I simplify this. This is f prime gh plus, you see that f going in there? F g prime h plus, again with that f going in there, f g h prime. So notice what happens. It's actually kind of cool. Derivative of the first, here's the second and third unchanged. First times derivative of the second, that guy unchanged, and then first, second, derivative of the third. So you're just putting each derivative with the other 2 guys. So if we were to kind of use that idea, and this can be extended to many, many factors, we could say that y prime equals, okay, the derivative of the first one is 1, and then we just put the second 2, don't change them. Okay, now let's do the first guy without changing him, but the derivative of the second one, and then the third one without changing him. And then for the last one, we're going to do the first one unchanged, second one unchanged, derivative of the last one. And notice the derivative of x is just 1. Okay. So now if we were to simplify that, this is just a bunch of FOILs, which is kind of nice. So that's x squared. The outer and inner would give us 10, and then a 24. For the next one, we'd have x squared. The outer and inner would give us an x, and then we'd have minus 30. And then for the last one, we'd have x squared. Outer and inner would give us minus x, and then minus 5. And I purposely wrote them that way so that we can combine our like terms. Let's add them up. So we have 3x squared, 10 plus 1 minus 1. And 24 minus 30 is negative 6 minus 5 is, oh, did I just do that badly? 4 times 6 is 24. Negative, okay. 4 times 6 is 24. Negative 5 times 6 is negative 30. And, oh, don't know where that one came from. This is negative 20. All right, so now let's add these together. So this is 24 minus 20 is 4, minus 30 is negative 26. So this is that first derivative. Now, second derivative, 6x plus 10. Third derivative, 6. And then when we get to fourth derivative, it starts to become kind of weird to keep doing the primes. So anything after third derivative, we just make sure this is in parentheses, otherwise it'll look like y to the fourth. But this is the fourth, and that would be a 0. So then you see the fifth would also be 0, dot, dot, dot. So forever and ever, 0 after that. So pretty slick. So this is, so we just used the product rule here. We just did, you know, we kind of looked at it and said, oh, what's going to happen? And this is what's going to happen. So it's kind of neat. All right. First and second with this guy, you can use the quotient rule on this one, but notice if you simplify first, it will make your life easier. So, and what I mean by that, this one, we can just divide this up. So this is t to the fourth divided by t to the fourth plus 6t cubed divided by t to the fourth minus 5 divided by t to the fourth. So see, a little bit of work beforehand will actually save you some work. So remember, when you divide, you subtract the exponents. So 4 minus 4 is 0, which is why there's nothing there. 3 minus 4 gives you the negative 1. And then he's got a 0 minus 4 gives you a negative 4. So if you take the derivatives from here, it will make your life a lot easier. So you can actually see that that's the first derivative pretty clearly, and then you can find your second derivative. So a little bit of work beforehand can save you a lot of work in the future. So this is just using product rule. Again, however much simplifying you want to do after that first product rule can help you. And then this one says, suppose u and v are functions of x and they're both differentiable at 0. And if you plug a 0 into u, you're going to get a 6. If you plug a 0 into u's derivative, you're going to get a 1. If you plug a 0 into v, you get 4. And if you plug a 0 into v's derivative, you're going to get 2. So it wants you to try to figure out the following values. So this is really just using the rules, and that's all. And now it does want you to find all of these at x equals 0. So see, this is just making sure that you know your rules. So this is u prime v plus v prime u. So then if we plug everything in, you see this one is a 1. This one is a 4. This one is a 2. And this one is a 6. So see, this is u prime of 0. This is v of 0. This is v prime of 0. And this is u of 0. So see, you can just plug all of these pieces in. So they really are just wanting you to use your rules and then use the facts that they gave you. So this is really a an exercise in making sure you know your rules. So just take your time, plug your numbers in, and do a little bit of arithmetic. All right, so this one wants us to find an equation for the line perpendicular to the tangent, to the curve at this particular point. So for that first part, this is just our kind of basic, like, hey, find the equation of a line. So for the equation of a line, we know we need to fill this in. All right, they have given us the x and y. That was very nice of them. So this is a 2 and this is a 2. But we have to find the slope. Now, how do we find the slope of a line that's perpendicular to a tangent? Well, dy dx, in other words, the derivative is the slope for the tangent. So what we're going to do, and actually I'm going to call that y prime instead. So we know that y prime is the slope of the tangent. So that means we're going to want its opposite reciprocal, right? Because that's for perpendicular. So if you recall that, if the slope of a line is m, then the line perpendicular to that has a slope of -1/m. So let's find y prime. This is a nice basic one. So 3x squared minus 4. Now they want me to plug a 2 into that. So y prime at 2 is going to be 3 times 2 squared minus 4, which is going to be 12 minus 4, and that's an 8. So the slope of the tangent line is 8, which means the slope of our line that we're looking for is -1/8. So there's my equation. So y minus 2 equals -1/8. X minus 2. So then we'll just simplify this. So y is equal to -1/8 x, and then this is going to be a plus 1/4. And then we've got to add that 2 over. And there's my 2. Okay, so we get -1/8 x plus 9/4. And this is the slope of the line perpendicular to the tangent. Okay, so that's the first one. The next one says, hey, what would be the smallest slope on the curve? The smallest slope on the curve. Gonna get rid of that. Okay. So I left the derivative up here because the derivative is the slope of the curve, right? And so we want to know when it would be its smallest. Well, let's look at it. This is, if you can graph it, it makes it very easy, but so this is a parabola. Parabola is usually a basic parabola x squared looks like this. This one has been multiplied by 3 and moved down 4. So the multiplying by 3, what that does is it stretches it vertically, and then the down 4, 1, 2, 3, 4, literally moves it down 4. So this in blue is the graph of the slope, okay? Where is it its smallest? At -4. You see, that's where it's the smallest. That is this, the smallest slope on the curve. Okay, so the smallest value it reaches is -4. All right, and then it says the curve has the smallest slope at what point? So we know that the x is -4, but to find the point on the original graph, right? This is asking about the curve itself. We want a point on the curve. We're going to go back to the original, you guys. So I want to plug a -4 into the original. And that is going to be 4 times 4 is 16 times 4 is 64. And that'll be a plus 16 plus 2. 14 minus 6 is 8. 5 minus 1 is 4 plus 2. So -46. If I did my arithmetic there right. So here's the point on the original graph where that is located. So the smallest slope is -4 because that's the smallest this reaches, right? This parabola represents the slope. What's the smallest slope? Oh, I can't believe I said, okay, back up here. I'm awful. The smallest slope is y equals -4. So go back. Sorry about that. So The smallest slope is -4. So what is the x value that corresponds to that? That's what we want. Okay, so I just kind of did that backwards. And so then for the last one, it says to choose, oh, darn it. Okay, so A was choose the correct answer below. Which question is that referring to? Okay, so that was our first one, -1/8 x plus 9/4. There's our second one, the -4. Oh, sorry, I didn't proceed to find where it was. So I originally had said x was -4, which was not right. Y is -4. So we need to see where that comes from here. So the actual point on the tangent, or on the derivative, this was the point 0, -4, which means we want the x value to be 0, not the -4, because that's the y value. So we're just going to do y equals, this is back to the original, remember, 0 cubed minus 4 times 0 plus 2. So y is 2, which means the point on the original graph is 0, 2. So sorry, I didn't finish that. Okay, back to the beginning. That's where the question for C is. It says find equations for the tangents to the curve at the points where the slope of the curve is 8. So now what they want me to do is set the derivative equal to 8 and figure out where that happens. So recall that the derivative was 3x squared minus 4. So we want to set this equal to 8. So we can just move that 4 to the other side. Divide both sides by 3. And then we're going to square root both sides. Don't forget when you do that to do your plus or minus. So there are two x values here. Plus and minus 2. So these are the two locations where our slope is equal to 8. So now we're just going to find the equation. So y minus y1 equals m times x minus x1. So we know that m is going to be 8 both times. We know that x is going to be positive 2 for one of them. So the y value that goes with that, we would find that by going back to the original. But notice they actually already did that work for us. That was nice of them. So we actually know it's going to be 2. So this would be y minus 2 equals 8x minus 16. Add the 2 over there. And we get -16 plus 2 would give me the -14. So there's one of them. So now I also need to figure out what the y value is when x is -2, so I can plug that in. So again, going back to that original, I want to plug in a -2. So notice that would be -8 plus 8 plus 2. Which is going to be, I did put that in, right? -8 cubed is -8. -2 cubed is -8. -2 times -4 gives you a +8. Yeah, that's just a 2. So y minus, the 2 is the same, but this is now x minus a -2, which makes it y minus 2 being 8x plus 16. And then we'll add that 2 over and we get an 18. So these are the two places where the slope is 8. So that is, that is A. So again, just lots of interpreting going on there. So this one is same type of question, just worded a little differently. So it says find all the points on the original graph. So if you have to find any y values to finish your pair, your ordered pair, you're going to go back to that original graph. But it says with tangent lines that are perpendicular to the line y equals 2x plus 3. So they're still giving us the slope of the curve, just again in a roundabout way. So if I'm perpendicular to this line, then my slope is going to be -1/2. You see his slope is 2. I'm perpendicular to him, so my slope is -1/2. So what you're going to want to do is do y prime equal to -1/2. Okay, so that looks a little bit funny, but so take the derivative. Okay, oh, be careful. You cannot split this one up like that, or however you might think to. You can't do that because it has 2 terms in the denominator. So whichever way you want to do it, though. Well, I mean, I guess we got to kind of use quotient here, right? So derivative of the top times the bottom minus derivative of the bottom times the top divided by the bottom squared. And this is what you're going to set equal then to -1/2. So the x values that you find, it looks like you're going to find 0 and 4. So then to find the originals, there's a really bad freeze frame, go back to the original. Okay, so you're going to find the x values from this equation and then go back to the original and plug those in. All right, I think that's it. It's not it. Goodness gracious. Okay. So here is the product rule, just kind of looking a little bit differently. So they have uv prime plus vu prime. It says what would be the analogous formula for the derivative of the product UVW. We actually saw that earlier, right? It was U prime VW, UV prime W, UVW prime. So it's actually kind of neat. So what if you had 4? Do you think the same thing would happen? Probably. So then it says, can you kind of extend that idea? So this is actually very useful, and it's neat to kind of derive it on your own. At least I think that's neat. So you can play around with that one. This number 14, it looks like we're doing a practical type problem, an applied problem. So it says if gas in a cylinder is maintained at a constant temperature, T, the pressure P being related to volume by this formula. So you may have seen this formula before, but P is equal to nRT over V minus NB minus AN squared over V squared. The A, the B, the N, and the R are all constants related to the particular gas that you're looking at. So it wants me to find the derivative of P with respect to V. So what you've got to do here, it's the same thing as before. You just really have to get in your mind that all these pieces are not variables, they're just numbers. And it tells you here that T is also constant. So all of these are constants, which means the only variable over here, so we have, well, P is equal to nRT over V minus NB minus AN squared over V squared. So you see those V's are the only variables. So when I go to do dP over dV, we can use quotient rule on this first one. If I take the derivative of the top, everything in orange is a constant. It's just a number. It's a 5 or a 7 or an 8 or a 9. So the derivative of the top is 0 times the bottom minus the derivative of the bottom is just 1, because you see the NB, his derivative is 0 because he's a constant. So derivative of the bottom times the top, all divided by the bottom squared. All right, so that's this part. Now let's look at the second part. So this is going to be minus this entire thing I'm about to write. So we're going to do derivative of the top is 0 times the bottom minus the derivative of the bottom. This is an actual variable. So 2 out front, subtract 1, derivative of the bottom times the top divided by the bottom squared. Okay, so you see how I treated everything in orange as a constant. All right, so now I'm going to just come above this and we'll simplify this. We got a lot of zeros in there. So this, well, not a lot, but that whole thing is gone and that whole thing is gone because they were just zeros. So we've got that dP dv is equal to, so we have a negative nRT divided by v minus nb squared. Now notice that's, let me do a different color. Here's a minus and here's a minus. Those two minuses are going to make a plus, so plus, and then this is 2an squared v. Oh, there's one v there and four v's on the bottom. So we can actually, this v and, well, this is v to the fourth, and one of those v's can divide out. So we really have 2an squared divided by v to the third. So that's pretty slick. Your question will probably be, well, the same question. So just be very careful writing it out, and then make sure that you're comfortable with saying, oh, he's just a constant. He's just a constant. The derivative of a constant is 0, so you don't need to worry with him. So it looks like our answer is going to be, what is that, b, negative nRT plus 2an. Yeah, so our answer here is going to be b. And that is the end of kind of our first, let's use derivative rules. So